Deductive thinking and inductive thinking represent two distinct approaches to reasoning and problem solving that have been central to human cognition and inquiry for centuries. While both methods share the goal of drawing conclusions from evidence and observations, they differ in their underlying principles, processes, and applications, each offering unique strengths and limitations that shape their utility in different contexts and domains of knowledge. Deductive thinking, also known as deductive reasoning or deduction, is a top-down approach to logic in which specific conclusions are drawn from general principles or premises. In deductive reasoning, the validity of the conclusion is guaranteed if the premises are true and the logical rules of inference are followed. This method of reasoning is often associated with formal logic and mathematics, where the rules of deduction are used to derive new truths from established axioms and theorems. The classic example of deductive thinking is the syllogism, a logical argument that consists of two premises and a conclusion. For example, Premise 1, all men are mortal. Premise 2, Socrates is a man. Conclusion, therefore, Socrates is mortal. In this example, the conclusion, Socrates is mortal, logically follows from the premises, all men are mortal and Socrates is a man, through the process of deductive reasoning. If the premises are true, then the conclusion must also be true, regardless of any additional information or context. One of the key strengths of deductive thinking is its ability to guarantee the truth of the conclusion if the premises are true and the logical rules of inference are followed. This makes deductive reasoning particularly useful in contexts where certainty and precision are paramount, such as mathematics, formal logic, and certain branches of philosophy and science. However, deductive thinking also has its limitations. Because deductive reasoning relies on general principles or premises to derive specific conclusions, it is only as reliable as the premises themselves. If the premises are false or based on faulty assumptions, then the conclusion will also be false, regardless of the validity of the logical process. Moreover, deductive thinking is inherently conservative and inflexible, as it relies on existing knowledge and established principles to draw conclusions. This makes it less suitable for generating new hypotheses or exploring novel ideas, where uncertainty and ambiguity are prevalent. Inductive thinking, also known as inductive reasoning or induction, is a bottom-up approach to logic in which specific conclusions are inferred from empirical observations or patterns in data. In inductive reasoning, the validity of the conclusion is based on the probability or likelihood of the conclusion being true given the available evidence. Unlike deductive reasoning, inductive reasoning does not guarantee the truth of the conclusion, but rather seeks to establish the plausibility or likelihood of the conclusion based on the available evidence. The classic example of inductive thinking is the scientific method, which relies on observation, experimentation, and data analysis to generate hypotheses and draw conclusions about the natural world. In the scientific method, scientists collect empirical evidence, formulate hypotheses to explain the observed phenomena, and then test these hypotheses through experimentation and observation. If the results of the experiment support the hypothesis, then it is considered to be provisionally true, pending further verification and testing. One of the key strengths of inductive thinking is its ability to generate new knowledge and insights by identifying patterns, trends, and relationships in data. Inductive reasoning allows researchers to make informed predictions about future events or observations based on past observations and empirical evidence, making it particularly useful in scientific inquiry and data-driven fields such as medicine, economics, and social sciences. However, inductive thinking also has its limitations. Because inductive reasoning relies on probabilistic inference rather than deductive certainty, the conclusions drawn from inductive reasoning are inherently uncertain and subject to revision in light of new evidence or observations. This makes inductive reasoning more prone to error and bias, as researchers must carefully weigh the strength of the evidence and consider alternative explanations for their observations. Moreover, inductive thinking is often limited by the scope and quality of the available evidence. If the data is incomplete, unreliable, or biased, then the conclusions drawn from inductive reasoning may be inaccurate or misleading. Additionally, inductive reasoning is more susceptible to cognitive biases and logical fallacies, such as confirmation bias and sampling bias, which can distort the interpretation of data and lead to erroneous conclusions. In summary, deductive thinking and inductive thinking represent two complementary approaches to reasoning and problem solving that have been central to human cognition and inquiry for centuries. While deductive thinking relies on general principles or premises to derive specific conclusions with certainty, inductive thinking draws conclusions from empirical observations and patterns in data, relying on probabilistic inference to establish the plausibility or likelihood of the conclusion. Both methods of reasoning have their strengths and limitations, and their utility depends on the context, goals, and requirements of the problem or inquiry at hand.